All right, let's dive in. Today, we're jumping headfirst into the invisible war that's being fought all around us every single second. We're going to break down cybersecurity, from the attacker's playbook to the defender's arsenal, so you can really understand the forces that are shaping our digital world. I mean, just stop and think about this for a second. Every single email you send, every photo you post, every dollar you transfer, it's all just data moving through a digital war zone. So how in the world does it survive? This one question is really the key to our whole explainer today. It's all about that constant fight between the people trying to wreck your data and the systems we've built to keep it safe.
So before we get into all the cool attacks and defenses, let's first get a lay of the land. What exactly is the battlefield? What are we really fighting to protect here? And what does security even mean in this digital age?
You know, it really all boils down to this. Every single security system you've ever used, from a password on your phone to a massive corporate network, is built to protect just three fundamental ideas. You can think of them as the three crown jewels of cybersecurity.
And here they are, the CIA triad. And no, don't worry, it's got nothing to do with spies. It just stands for confidentiality, integrity, and availability. Let's break it down. Confidentiality is all about keeping your stuff secret. Integrity is about making sure your data is trustworthy and nobody's messed with it. And availability? Well, that's just making sure you can actually get to your data when you need it. So secrecy, trust, and access. That's the whole game right there.
Okay, so now let's meet the villains. Every single attack you hear about in the news, whether it's a huge data breach or just a friend's social media getting hacked, is designed to smash one of those three pillars we just talked about. Let's check out their main strategies.
First up, we've got eavesdropping. And it's pretty much exactly what it sounds like. It's the digital version of someone secretly listening in on your private phone call. The attacker doesn't change anything, they just listen. And if they succeed, well, your secrets aren't secret anymore. That's the pillar of confidentiality crumbling down.
Now this next threat is a whole lot more active. The goal here isn't just to listen in, it's to actually change the data while it's on its way. Imagine you send a bank transfer for $100, but an attacker snags it mid-flight and changes that number to 10,000. Suddenly, you can't trust the data anymore. That is a brutal attack on integrity. And finally, we have an attack on availability. So if an attacker can't steal your data and they can't change it, what's left? Well, they might just try to block you from getting to it at all. They can flood a website with so much fake traffic that it just gets overwhelmed and jams up, shutting down for all the real users. The service becomes unavailable. So we've seen the attacker's playbook, and yeah, it can seem kind of grim. But for every single threat out there, an incredible defense has been engineered to fight back. So now let's flip the script and look at the defender's arsenal, the tools we use to protect those three pillars of security. Our number one weapon against eavesdropping is encryption. And the logic here is actually pretty simple. If an attacker can't read the data they steal, then it's totally useless to them. Encryption basically takes your normal readable information, what we call plain text, and scrambles it into unreadable gibberish, or ciphertext. It's a secret code that can only be unlocked with a very specific key. Now, encryption isn't just one thing. It comes in two main flavors. On the left, you see symmetric encryption. Think of this like a lockbox that has just one key to lock and unlock it. It's super fast, which is great for encrypting huge amounts of data. But it's got one big problem. How do you get that single key to the other person without someone intercepting it? And that's where asymmetric encryption, on the right, comes in. It's a brilliant solution that uses two different keys, a public one you can give to anyone and a private one that you keep totally secret. This is where the magic really happens. The way asymmetric encryption works is just beautiful. It's like you send your friend an open padlock. That's their public key. Anyone can take that padlock and snap it shut on a box. But once it's locked, the only person who can open it is your friend, because only they have the unique private key. This simple but powerful idea completely solves the key sharing problem, and it's one of the absolute cornerstones of the internet. Okay, so secrecy is covered. But how do we fight back against data tampering? The answer is something called a digital signature. Think of it like a high-tech, tamper-proof wax seal. A sender uses their private key to create this unique signature for a message. If even one single letter of that message is changed on its way, that seal is broken and the signature is invalid. This guarantees two crucial things: who sent it and that it arrived exactly as it was sent. To guard against attacks like denial of service, we need digital gatekeepers. We call them firewalls.
And as you can see here, they've gotten a lot smarter over time. The early firewalls were like a basic ID checker at a concert, just looking at the source and destination addresses. But modern stateful firewalls, they're way more like a seasoned bouncer who actually remembers you, understands the context of your conversation, and can spot when something just doesn't feel right.
So how does all this stuff, encryption, keys, digital signatures, actually come together in the real world? I mean, these aren't just abstract ideas. They're the actual building blocks for the secure tunnels that you and I use every single day to stay safe online.
You know that little padlock icon you see up in your browser's address bar? Ever wonder what it's really doing? Well, it represents this incredible process, the HTTPS handshake. In literally a fraction of a second, your browser and the website perform this complex dance. They use the slow but super secure asymmetric encryption to prove who they are and safely swap a brand new secret key. Then they immediately switch to the much faster symmetric encryption using that new key to build a private, secure tunnel for your entire visit. It's amazing.
Now, a virtual private network, or VPN, basically takes that secure tunnel concept and puts it on steroids. It wraps everything your device sends and receives, every app, every website, inside a layer of powerful encryption and sends it all through a trusted server. This is absolutely critical for keeping your data confidential, especially if you're ever on a public Wi-Fi network at a cafe or an airport.
But here's the thing you have to remember. This digital battlefield is never, ever static. As the attackers get smarter and develop new weapons, the defenders have to constantly innovate just to stay one step ahead. So for our last section, let's take a quick look at where this fight is headed.
This quote right here, "Never trust, always verify," is the heart of a massive paradigm shift in security. For decades, the old model was what we called the castle and moat. Build a really hard outer shell, and once someone's inside, you kind of trust them. Well, that model is completely broken now. The modern approach is something called zero trust. So what does zero trust actually mean? It means we're throwing that old castle idea out the window. It works on one simple paranoid principle. It doesn't matter if you're in the office or sitting at a coffee shop. Every single request to access anything needs to be verified and authorized every single time. This approach dramatically limits the amount of damage an attacker can do, even if they manage to steal someone's password.
And of course, you can't talk about the future without talking about AI. The sheer speed and volume of modern attacks are just too much for human analysts to keep up with. AI is becoming our tireless digital watchdog. It's incredibly good at learning what normal looks like on a network, so it can spot tiny, subtle signs of an attack in seconds, something that might take a human analyst hours or even days to find. And all of this brings us to our final, lingering question. This battle for our data is a never-ending arms race. As new technologies like AI and even quantum computing come online, both the weapons and the battlefield itself are going to change in ways we can't even imagine. The most important thing to remember is that security isn't some destination you reach. It's a constant, evolving process. And that's something to think about.